This continues the series on basic training, and this is part 2 of transferring circuit diagrams into block diagrams. In the last video, I showed how in DC and AC circuits analysis, we subtly move from a loop analysis type of circuit where the focus was mainly on having an energy source delivering energy to the load. We can deliver the energy through wire or through an electrical resistive network to control the level of the energy. But the idea was you have an energy source and you have a load, and your goal was to construct a network that would allow energy to be passed to the load in the correct way. As we moved on, we looked at different types of networks. Series networks, parallel networks. We introduced new components such as capacitors and inductors. And we started using different types of energy sources. This source of energy is an AC, and we analyze circuits using an AC energy source. This is an energy source that changes its value over time. And we analyze the circuit the same way we did with DC, trying to find out what happens. Where is the voltage? Where is the current? What are the values? And since we had another parameter called frequency, we had to do a two-dimensional analysis where we wanted to know what will be the voltage depending upon the value of the frequency. And then towards the end of the course, we introduced a new concept called filters. And this is where I believe the problem started. The problem started with introducing an idea without properly preparing the student for the new idea. You combined a loop analysis concept with a system analysis concept, hereby not giving the student a proper foundation to deal with the transition. But in the last video, we cleared that up and showed how circuits can be transformed into system format and how that format can be replaced with a single block to describe its behavior as a relation between output and input, and showing you the final form of the block. In this video, we're going to focus more on how do we change circuits into the block. Here's a circuit that I found in the past. If you start breaking this circuit up into different parts, I have a circuit here. How do I know it's a circuit? Very simple. I have a power supply, and I have a ground, and I have a path for the current to go from the power supply to the ground. So for all practical purposes, I have a closed circuit. It may not look like it, but if you draw the power supply, then you can see that there is a path. So this would be considered a valid circuit. If you look closer, you'll see that there are many paths for current to originate from the power supply. We have something here, and we have this large component right here that has its own power supply. Then we have this medium-sized component that basically has its own power supply. And then we have this last component on the right that has its own power supply. So if you think about it, you have 1, 2, 3, 4, 5 major circuits. So what we're going to do is we're going to change those into blocks by following the lines. This block right here consists of two resistors in series with a line coming out, being in the middle. So that crosses over into another circuit. It sort of goes into the second circuit over here. Actually, it crosses over into the third circuit. We have another situation where this here is a circuit, and then there's a line that comes out of its area and goes into the third circuit. So as you can see, this circuit here becomes very important because it seems like all lines are coming to here. I'll draw another line to separate this large component. It's an integrated circuit. There's a large number of diodes and transistors and resistors and capacitors and other components that are inside this module. This is what we call a multi-terminal module. And you see lines coming out. Three of these lines go to this section. And finally, one of those lines from the middle module makes its way all the way to the last section. Now we're going to start changing those into blocks. I have a general idea of what this is going to look like. So I'll make it easier by saying or stating that there is something in the middle called a controller. And this controller basically has two inputs and two outputs. We're going to take these three lines and we're going to group them together and call it a single output or a single connection. If you recall, the very first block has an arrow going into the middle module, and the second block also has an arrow going into the middle module. So we can say this is input device number 1 and input device number 2. I'll call them blocks. Block 1, block 2. This is the control block. This device here would be considered a block because it receives voltages from the C block. But I'm going to draw a line here and put the number 3 to indicate that there are 3 wires that are needed to communicate with this block. So I'll call that B3. And then lastly, there is a final block on the far right. If you remember, this component or module is receiving some information from the controller. So that will be the final block, and call that block 4. So here would be our block diagram, and it follows the same rules as our previous. We do not have any ground information. We only are interested in the energy that is being transferred from one place to another place. Now this block is an individual block and it has an input and it has an output. You can consider that as the C block. A C block has all the control, and there are things going into it and there are things coming out of it, and there's a relationship between the output and the input. So there is some type of gain. What's different about the one before and the one we're doing now is that we're drawing the blocks that are creating the signals to put into the C block, and we're drawing blocks that are receiving the information from the C block. Before, we only represented the input as some unknown voltage, and some unknown voltage will create some kind of output voltage depending upon what the definition of AV is. What's its job or its transfer function? In this block, it's the same idea. We have some type of function and we have some inputs, but this time we have multiple inputs and multiple outputs. And the voltages that are being sent to the controller are not coming from anywhere. They're coming from a particular circuit. So something must happen over here in order to create voltages here, and this will deal with those voltages and create voltages here that will eventually operate what's going on in these blocks. So this is called a block diagram. Now giving someone a circuit and asking them to make a block diagram of that circuit is relatively easy. You only need to study the circuit and find out how the wires are being placed. Fortunately, this circuit was organized in such a way that made it very easy. But in other circuits, such as circuits like this, it may not be as easy to trace. But if the engineer who designed the circuit follows the rules, then it will be a lot easier to determine where are these sections and how we can isolate those sections and change them into blocks. That's the end of this session on changing circuits to a block diagram.